Alright, so here is a practice of calculations regarding bond energies and enthalpy change. So let's try to see what we can do here or how we can solve the bond energies or the enthalpy change for some reaction. Alright, using enthalpy change using bond energies. So these are the four steps that we'll be following to calculate the enthalpy change of any reaction. Number one, you are given an equation, you need to balance it. Any equation which is not balanced, it is useless for the calculation. Alright, so first of all, let's try to balance this first equation that we have. CH4 plus O2, it gives CO2 plus H2O. Alright, and then we'll balance it, then we'll draw the structural formula. Why is it necessary? Because it will help us in the third step. It will help us to identify the bonds that are present in a molecule, and then it will help us to count those bonds so that we can use the bond energies for the mathematics that is involved. Alright, so let's continue with this first example. We have to balance it first. Let's start with carbons. We have one carbon on the left side and we have one carbon on the right side. Carbons are balanced. Alright, next we have hydrogen. We have four hydrogens on the left side and we have two hydrogens on the right side. So you know what to do with this. Multiply this by 2, multiply this by 2, and hydrogens are now balanced. Alright, so next is oxygen. You have two oxygens on the left side and you have 2 plus 2, 4 oxygens on the right side. You know what to do. Multiply this by 2. The equation is now balanced. Step 1 is done. Let's move on to step 2. And before we start our step 2, let me just rewrite this balanced chemical equation which we'll be using for further calculations. Alright, steps 2 says draw the structural formula. Now let me just draw the structural formula. CH4, it looks something like this. Alright, so we have carbon in the center and 4 hydrogens surrounding it. And then we have 2 because it's 2 and oxygen molecule. Oxygen molecule looks like this. It is oxygen double bond oxygen. And then we have carbon dioxide. Carbon dioxide is like this. A carbon with 2 oxygens. And then we have 2 times, or we have 2 water molecules. Alright, so that's it. That's step 2. We have drawn the structural formulas. Now this will enable us to count and to identify the types of bonds that are present in each molecule, which is step 3. Identify and count the types of bonds. So we can do it. So if you look at this, then we have a carbon hydrogen bond over here, and we have a carbon hydrogen bond over here, and we have a carbon hydrogen bond over here, and another carbon hydrogen bond over here. So we have a total of 4 carbon hydrogen bonds. Alright, so we have identified the bonds and then we counted the bonds. 4 carbon hydrogen bonds, and then we have 2 oxygen bonds. Simply no difficulty in identifying or calculating the bonds. And now here is a little complication again. We have a carbon double bond oxygen and we have another carbon double bond oxygen. So we have 2 of carbon double bond oxygen bonds. And then now this is crucial. You need to understand that one water molecule, it consists of 2 OH bonds. Alright, now these 2 OH bonds that are highlighted, these are the part of one water molecule. Now because we have 2 water molecules, So we'll have a total of 4 oxygen hydrogen or hydrogen oxygen. It is the same thing. All right, we have 4 OH bonds. Now that's step 3. We have identified the types of bonds and then we calculated or we counted, sorry, not calculated, we counted the types of bonds. That's step 3. Step 4 says do the maths. That's the main thing. That is what, or that is why we did all the first 3 steps. So for this maths, what do we need to do? We need to simply use our formula that we have learned of enthalpy change, that is delta H equals minus exo plus endo. Alright, and we know that exothermic part is the product side. Alright, exothermic part is the bond making part or the bond formation part. And then we have endothermic reactions, and for this endothermic reactions are the reactant side where bonds are broken. All right, bond breaking part. Now it's necessary that the old bonds are broken, only then the new bonds of products can be formed. All right, first the reactants bonds are broken, then the products bonds are formed. So let's get back to our equation, or let's so delta H equals minus exo plus endo, and we have exothermic part. On exothermic part on the product side we have these bonds, and on the reactant side we have these bonds. Alright, so let's move on. We have to do minus exo first. So I'll put a minus sign over here and I'll look at my products. And my products have 2 times C double bond O plus 4 times O single bond H. That's it. That's the exothermic part. Let's move on to the plus endothermic part, and that is the reactant side. And on the reactant side, I have 4 CH bonds plus I have 2 oxygen-oxygen bonds. That's my reactant side. That is the endothermic part. Now, last step, all we need to do is to put the values of bond energies. Alright, so I put a minus sign over here because it is the exothermic part. We are talking about minus exo part first. So I'll put a 2 over here and then I'll put the bond energy of carbon double bond oxygen, and that I'll see from the table it is this 743. Alright, so 2 times 743. Remember, we have a minus sign over here, so we do not need to repeat plus or minus over here. Alright, that is all catered by this minus plus this plus. That's it. And then we have 4 times bond energies of OH bonds. And we'll see it from the table again. OH or HO, it's 463. So 4 times 463. And then we have our endothermic part. And that is 4 times bond energy of CH bond. And that is CH bond is over here, 412. 4 times 412 plus 2 times O double bond O. And that is the last data set is 498. 2 times 498. That's it. So all you need to do as simple maths over here, this is negative part, this is positive part, minus, let's say, I don't know, I haven't calculated here, minus x plus y, or not minus x plus y, or just do the maths yourself and you'll have a total bond, you'll find out the bond energy in kilojoules per mole. Alright, that's a very basic simple calculation. I want to explain the other parts as well. I won't be solving them over here, but I'll try my best to explain it to you. Now this is a molecule of ethine. Ethine looks like this. It has a carbon triple bond carbon, and then it has a carbon single bond hydrogen and a carbon single bond hydrogen. Alright, so you need to balance the equation first, and then you need to identify and count the bonds. And identification is carbon triple bond carbon. It is over here in the data. So you'll use this bond energy, and then you'll use carbon hydrogen bond, 2 times carbon hydrogen bond, and that is 412. And then hydrogen is very simple, it is H2. Alright, so this is HH bond, this is the bond energy of hydrogen involved. So that is your reactant side, that is the endothermic part. And then you have ethene molecule, which is C2H4. It has one carbon double bond carbon. Alright, this is 612, and then it has one carbon hydrogen bond, the second carbon hydrogen bond, third carbon hydrogen bond, and a fourth carbon hydrogen bond. Or it has 4 carbon hydrogen bonds. So you'll use the bond energy, carbon hydrogen bond energy from the table, and you'll simply move on with the steps. And the next we have again C2H4. It is the same molecule as this. Oxygen, we have done it over here. CO2, we have done it over here, and water, we have done it over here. And then we have hydrogen, oxygen, and water. Very simple. Now, this is important. Fifth part is important. We have carbon over here. Carbon is in its elemental form. It is not bonded to any other element. Alright. So that is why we will not be using its bond energy. We'll only be using the bond energy of oxygen in the reactant side and carbon dioxide in the product side. Alright. So carbon is an elemental form. It will not be involved in the calculations of bond energies. Alright. It is not bonded. Obviously, it makes sense. It is not bonded to any other element. Alright. So it won't have any bond energy. That's it. I hope it helped, and I hope you'll be able to solve these questions now. Let me know in the comments if there is still any confusion. Wish you best. I hope it helped.